See friends, here today we are going to take the next part in similarity. Okay, previously we studied that 1.1, 1.2, but in these two exercise practice sets, not a single time we can get the word similar. But now we are going to discuss about similarity only. Yes, this particular part already we discussed in 8th standard. Okay friends, but before that one I am going to discuss first about congruency. When the two triangles are said to be congruent, do you know? Yes, there are some tests. Yes, see here first. Suppose we want to prove these two triangles are congruent. Okay, look here. Okay, now to say the two triangles are congruent, there are some conditions. But before that one, always three sides and three angles must be there in two triangles. Okay, that means in all there are 6 conditions. Understand? 3 sides and 3 angles. Out of all these means what? Here when the two triangles are congruent means here this is congruent to this side, this is congruent to this side, and this is congruent to this side. After that, for 1, 2 means this angle with this one. Afterwards 2, 3, this angle with this one, and the remaining angle with this one. Here these are the ways. But all that 6 conditions, they are not given to us. Out of them, only 3 specific conditions only given to us. That particular part already we discussed in last year, congruency of triangles. Like this one here, S test. Only they are given to us 3 corresponding sides only. After that, SAS means what? 2 sides and 1 angle including with them. That particular part only given. After that, ASA means 2 angles and 1 included side is given. Okay. Afterwards, SAA. This one you may write here AAS. Okay. But this one is equivalent to this one. So that is why this particular part already we eliminate from that syllabus. But we can use. Why eliminate here? This one and this one both are same. Why? Because the third angle is automatically congruent. By that reason, this one is no need to take. But we can apply in the solution. Okay. And last one is what? HST. Means what? Hypotenuse side test. For this test, we need the triangles must be right angle triangles. Okay. This is everything about congruency. Here also, whenever the two triangles are congruent, out of all these 5 to 6 tests, remaining conditions are automatically satisfied. So suppose remaining conditions are like sides, then we can say here corresponding sides of congruent triangles. Remaining conditions are like angles, then we can write here corresponding angles of congruent triangles. Okay. So today in this similarity also we are going to take very similar procedure. So now first of all, before that one we know here the name of triangle we can write by 6 ways. See here, A, B, C. The name of this triangle we can write by 6 ways. Do you know? See first here. Look here. A, and here A. Look here. Like this. Remaining vertices are BC. So we write here like BC, CB. Okay? Like this one. Right? A again here. Similarly, again I will write in middle part A. So BC means BC, CB. Here it is A, BC, CB. So these are the procedure to write the name of any triangle by 6 ways. Understand? We need this one. Why? Because whenever we are going to take the two triangles, when we are going to adjust it, there are 6 conditions. Okay, each condition is called as 1-to-1 correspondence between the vertices. Okay friends, whenever the two triangles are similar, we need 6 conditions and they are like 3 corresponding sides and 3 corresponding angles. How the 3 corresponding sides are there? The 3 corresponding sides are in proportion and 3 corresponding angles are congruent. Okay? So how the 3 sides are in proportion? See, suppose here it is 5 or you may write here 6 and here it is 2. then their proportion is what? 6 upon 2 means what? 3 upon 1. Okay, see here, this is 9 and here it is 3. So 9 upon 3, again it is what? 3 upon 1. Now here it is suppose 12, here it is 4. So 12 upon 4, 3 upon 1. So here this is the way 3 upon 1, 3 upon 1, 3 upon 1. Not always, but all these 3 are every time same. Then we can say all the 3 sides are in proportion. Okay. Now angles as usual. Suppose this angle with congruent to, yes, 6, 12. So we have to take which angle? Tell me first. 6 and 12. So here 6 and 12 means what? You can take here 6, here 2. So 3 upon 1. 9 and 3, that means this angle with this one, again 12, 4, this angle with this one. Now 6 and 12 means we have to take this one. So this is called as corresponding angle. Similarly 6, 9, here it is, yes, may I take this one? Yes it is, this to this, and remaining angle is like this one. This is the procedure to identify exactly which angle is congruent to corresponding other triangle's angle. Okay? So this is very, very important. And whenever you are going to write the two triangles are either congruent or similar, that vertices should be in one-to-one correspondence. Okay friends? When you are writing in triangle and triangle, at that time you can write name of triangle anyway. But when you are writing the two triangles are congruent, at that time we have to write the names of that triangle must be in one-to-one correspondence. Okay? Now we'll take one by one this test for similarity. First of all, for a given one-to-one correspondence between the vertices of two triangles, three corresponding sides of first triangle are in proportion with three corresponding sides of other triangle, and three corresponding angles of first triangle are congruent to three corresponding sides of other triangle. So here these are the 6 ways, 6 conditions to get the two triangles are similar. But out of all that 6 conditions, not always we need all 6 conditions. We need 3 specific conditions. If we know, then also we can write the two triangles are similar. So in this here, in similarity part, which are the 3 tests are there or tests are there? See here, S test. After that, S test. And then A test. Here we are going to follow these 3 tests. For this what we need? S test. Only sides are given. Means what? For a given one-to-one correspondence between the vertices of two triangles, 3 corresponding sides are in proportion of both the given triangles, then we can say the two triangles are said to be similar by S test. Okay? Then now remaining conditions are automatically satisfied or fulfilled. Which are the 3 remaining conditions? In SSS, remaining conditions are nothing but all the 3 angles are automatically congruent, but they are also corresponding angles. Okay? Now after that, SAS means 2 sides are in proportion, 2 corresponding sides are in proportion, included angle is congruent of both the triangles. Then we can say the 2 triangles are said to be similar by SAS test. Here also there are remaining conditions. One corresponding side is in exactly same proportion and remaining 2 angles are congruent with corresponding angles. Okay? Now here AAA test, or you may say here AAA test. What is the here? For a given one-to-one correspondence between the vertices of 2 triangles, 3 corresponding angles of both the triangles are congruent. Then we can tell us the 2 triangles are similar by AAA test. But remember friends, here suppose AAA test, one angle is not given. Only they are given to us 2 angles. Then tell me what about the third angle? Third angle is we can find by using sum of measures of all angles of any triangle is always 180. By using this property, we can find the third angle. That means this A means third angle. If they are not given, then also by AA test only we can prove the two triangles are similar by AA test, because the third angle, measure of third angle, we can find very easily by using that property. That we know sum of measures of all angles of any triangle is always 180. Using this property, we can find third angle. That means sometimes they are given to us three angles, but no need to take the third angle. Just take any two of them. Then we can prove the two triangles are similar by AA test. Understand, friends? Now, whenever you are going to use out of these three tests, any one of them, their remaining conditions are also satisfied, as like in congruency. Corresponding sides of congruent triangles, corresponding angles of congruent triangles. Here also we can write corresponding sides of similar triangles, corresponding angles of similar triangles. Like this we can use. Understand? So whenever we are going to solve the examples, at that time just try to identify. Here we are going to use exactly which test. So all the given information try to just write in the figure, or sometimes they are given to us like values are given. So just try to put the values in the given figure and try to think. Sometimes some angles are not looking, they are given, not given, then how can find? Suppose as like this one, here is one figure. Just try to look here. Okay, here. Tell me how many figures are there or triangles are there? We know two. Not two. There are three angles. If you observe here. Okay. Now this is one triangle. Okay. And we are going to take one more triangle. Is what? This one. This bigger one. Understand, friends? Look here. Is there anything you are going to observing? See, I am going to separate it. This is this side triangle and this is bigger one. Look here. Just try to concentrate here. If you observe here, this angle, which one? This side angle is common in both the triangles. So like this we are going to observe. This is not given, but we can observe here. So we can take this angle in both the triangles. That is why that angle is we have to take as a common angle. So this is the way. Sometimes they are given to us in, like suppose here it is, the triangles are given. This particular angle is not given, but we can take. Why? Because they are vertically opposite angles. So whenever they are given to us like this, we are going to just observe here. Understand? Just again I will repeat this one. SSS test, SAS test and AAA or AA test. Actually, to say the two triangles are similar, what we need? Three corresponding sides are in proportion and three corresponding angles are congruent. And vice versa also. Okay? Sometimes they are given to this much only. We can write directly the two triangles are similar. And when they are given to us two triangles are similar, we can write all these 6 parts. But not always we need these 6 parts to say the two triangles are similar. It is sufficient condition. Okay? Triple S means SSS test. Remember these two tests in both the side. Either it is in similarity also, in congruency also. One more thing is, when the two similar triangles or when the two congruent triangles are said to be similar, or when the two similar triangles are said to be congruent. So first of all we are going to discuss when the two similar triangles are said to be congruent. Yes, tell me. When the two similar triangles are said to be congruent. See here, at that time these particular kinds of examples may be asked for 1 mark either in MCQ or in question number 1B also. Just remember, when we are going to say the two triangles are congruent, their corresponding sides are congruent. Corresponding sides are congruent means what? If we take the corresponding sides ratio, it is exactly 1:1. That means when the corresponding sides of given two similar triangles is 1:1, at that time we can say the two triangles are congruent. Understand? This is very, very important. So by using all this information, we are going to solve some examples. See here friends, now we are going to take some examples from practice set 1.3 here. Okay, we'll take first one. See this figure here, and the question is what? In this figure, angle AB is equal to 75 degrees, angle ED is equal to 75 degrees. State which two triangles are similar and by which test. Also write the similarity of these two triangles by a proper one-to-one correspondence. Okay, this much particular part we have to solve. See in this figure, yes, you are observing there are two triangles, obviously. Okay, I will make separate here. Triangle ABC, okay, and triangle DEC. Okay, I will make separation first. I will write all the information what we know in the given figure. DEC. Which angle is 75 here? This is 75. And here, this is 75. Now, the information which is not given, but we can understand, that is what? This particular angle, this one, is in both the figures. That means this angle is said to be common angle. Now see here, in these two triangles, 75, 75, these two angles are congruent, means they are similar. By which test? AA test. Let's see here. But before that one, when you are going to solve, we are going to prove the two triangles are similar. At that time, first write the name of the triangle by any way. But when you are writing the two triangles are similar, at that time, you should write the names must be in one-to-one correspondence. See first here. I will write in triangle ABC and triangle DEC. Okay. Now look here. Angle ABC congruent to angle EDC. Why? Because each 75 is given to us. At the same time, angle C is congruent to angle C. We can write common angle. Okay. Therefore, these two triangles becomes now similar. So I write the name of triangle ABC, keep as it is. But when you are writing the name of this triangle, at that time, we have to check whether they are in one-to-one correspondence or not. How to check? See first. B to D. Okay, so now here it is B in the middle part. So we have to write D in middle part. C to C. That means C is in last. So write C in last. So in DEC, D and C both we wrote. But this E is not done. So wherever the place, at that time, at that place we have to write E here. This is the system to write one-to-one correspondence between the vertices. And this is by which test? AA test. Okay. Now they asked here by which test? By AA test. Now by which one-to-one correspondence? This is, but I will write again ABC one-to-one correspondence with EDC. This is the system. Understand friends? Very simple part this one. Okay. I will solve one more example, fourth one. See here, in fourth sum, what they are given to us here in this figure, ABC is there, AB perpendicular to BC, BQ perpendicular to AC. What they asked to us, see here, in the triangle ABC, AB perpendicular to BC, BQ perpendicular to AC, B dash P dash C, A dash Q dash C. Then prove that triangle CPA similar to triangle CQB. After proving this one, they are given to us AP equal to 7. Alright, AP equal to 7. And then BQ is equal to 8. This BQ is equal to 8 is also given. From that, again, BC equal to 12 is also given. And from all that information, we are going to find this AC. Okay, but before that one, we are going to prove CPA similar to CQB. Let's see here. First of all, whether you are going to observe in here two triangles, what they given to us, CPA, here it is, and CQB. May I make separate here? See first. This is the first one, and then this is the next one. Okay, what is the name of the triangle? Here it is A, P, C, and here it is C, Q, and B. Here it is perpendicular, here also perpendicular. So now we are going to observe here. We are going to prove these two triangles are similar. Just observe here, this is 90, 90. Okay, that one in both the triangles. With the same time, here it is this angle C, which is common angle. One more time, just in previous sum also that common C is there, and here also angle C is common. That means now it is very easy to prove the two triangles are similar. Again by AA test. Okay, we'll prove this one. See in triangle CPA. Okay, write the name of the triangle by the given one. But in the second one, you can write by any way. We'll get the same thing what we need. Let's see. CPA, and we need what? You can write here CQB or QBC. Write anything. But when you are writing similar, at that time you will get definitely the same thing. Okay, now see here. First one, angle SAPC congruent to BQC. Yes, tell me why? Because by each 90. Because perpendicular is given. Angle C is congruent to angle C. Why? It is again common angle. Okay. Therefore, we can write directly triangle CPA is similar. But don't copy this QBC as it is. We will write by one-to-one correspondence. See first, P to Q is given. Okay, where it is P? Again in the middle. Write Q is in the middle. C to C. C is first. Right here is in C first. And then which vertex remains? C and Q both completed and B is remaining. Write B where the place is. This is the procedure. And this is by which test? Again by AA test. This is what we have to prove. Once these two become similar, then corresponding sides are in proportion. Yes, because of that reason, here this AP is 7, BQ is 8, BC is 12, and AC we are going to find. So let's see here. And one more thing is very important. When the two triangles are similar, we have to write one-to-one correspondence. How can I write? CP upon CQ, and one-to-one correspondence. PA upon QB, and then CA upon CB. This is very, very important. Write first. CP upon CQ, PA upon QB, this side CA upon CB. This we can write corresponding sides of similar triangle. Now just try to put what we know here. Is there given to us CP is there? CP not given. Okay, don't take. CQ again it is not given. So just eliminate. Okay, now what about PA? This is 8. What about QB? Yes, PA is 7. Sorry, PA is 7. What about QB? It is 8. What about CA? That one we are going to find. And what about CB? 12. So just take that 12 to this side. What will get? Yes, 7 into 12 upon 8 is equal to CA. So by simplification, let's see what we get here. 4 2s are 4 3s are. So 7 3s are 21 upon 2. That means CA we can write how much? 10.5. Understand? This is the procedure to solve and to use similarity in these particular examples. Okay? See here. This is the fifth sum from practice. Look here. In this figure, PQRS is a trapezium. Okay, and this PQ and SR, both these are parallel. Now, this AR, which is 5 times of AP is given, and at the same time, AS is 5 times of AQ is given. From that all information, we are going to prove this SR is also 5 times of PQ. That one we are going to prove. Whenever like this information is given, at that time, we have to prove the two triangles are similar. So which two triangles are we are going to similar? So see here, if we take these two up, is there any that PS and QR are parallel? So no use to take that two triangles. So we are going to take these two, in which these two are parallel. Parallel means we can write that alternate angles are congruent. Okay, like this. See first, I am going to draw the figure here. What we need? Is it okay? Which are the names here? P, A, Q. Now here S, R and middle one A, R. Look here. First of all, this angle you can take as a congruent angle. Why? Because of alternate angle. Okay. Now you can take this one also. This one with this one. Or you may take this one to this one. Out of all these three angles, we can take any two of them. So now I'm going to take one angle is alternate and one vertical angle I will take. Then these two triangles will becomes they are similar. Okay. Now we can take by different way also. See here. This is trapezium, so we can write by AA test. But the same example we can prove by SAS test also. Why? Because of they given to us two sides are in same proportion. See here, AP is there, so this AR goes to that side. So AP upon AR, that is 5 on this side, 1 upon 5. And here also, means two sides are in same proportion with this vertical opposite angle is congruent. That means the same example we can solve by AA test as well as by SAS test. Okay? So now I am going to solve by AA test. See first here. What they are given to us first? May I write here PQ is parallel to SR. It is given. Okay? Now look here. Because of that reason, I'll take angles. Which angle we have to take here? I'll take this red. That is QPA. QPA congruent to ARS. Look here. AR, yes. This is from one and alternate angle test. One more angle I'll take here. That is, I will take vertically opposite angle. Angle PAQ congruent to angle SAR. This is by vertically opposite angle. Finish. Now these two triangles becomes now similar. So which two triangle here? I'll take first PAQ. Okay, similar to. Don't write SAR. Write first 1 to 1 correspondence. Check P to R. Where it is P first. So here is R. Afterwards A to A means A is in middle. So A. So which vertices remains here in this figure? That S remains. So we'll write here S. This is by AA test. Okay. Now look here. What they have given to us? The given information is also very important. AR is equal to 5 times of AP. Okay. But now I'll write the sides are in proportion. See first. PA upon RA is equal to AQ upon AS is equal to PQ upon IS. This is by corresponding sides of similar triangles. But now they were given to us either AR is equal to 5 times of AP or AS is equal to 5 times of AQ. This particular part is given. So now 5 and 6. What tells us? You can take. Where it is AR, here it is AR. We can write here 5 times of AP. Okay. Now this AS will also be there, but no need to take. Either this or this we can take here. So this particular part no need to take. So PA keep as it is. What about RA? This is 5 times of PA or you may write AP. Okay. Is equal to PQ upon IS. This is from 5 and 6. Now this PA getting cancelled. Okay. Now just go with cross multiplication. What we get here? RS is equal to 5 times of PQ. This is from 7th step. Like this we can prove. Here with same example we can prove by SAS test also. How? From these two it is given. So these two we can write in the first step and then writing their sides are in proportion like 1 upon 5, 1 upon 5 vertically opposite angle. Here that parallel also no need to take. Okay, like this way we can write the two triangles are similar and then their corresponding sides are in proportion. Remaining side is also in the same proportion. Understand? Look here in the 7th sum. Here quadrilateral A, B, C, D is a parallel one. They're given to us. Okay. Now here after extending, here it is point E, and if we join this DT which intersects BC at point E, this much information is given to us, okay, like this one. Now from that information we have to do here DE, okay, into BE is equal to C into T. That means everything is here about in these two triangles only. So where it is possible, one side take that side, one side take this side, then sides are in proportional, means we have to prove the two triangles are similar. So here the two triangles are similar, we are going to prove here. Okay, just observe here. Okay. Now we are going to prove these two are similar. Similarity means we need first always try to prefer to use AA test. See first. This one is what? We can say here it is alternate. In parallel, AB is parallel to DC, means we can say AT is parallel to DC, or you may take here BT parallel to DC. For that reason, we can take these two alternate angles are congruent. Okay, that means it is very enough to say the two triangles are similar by which test? AA test. Understand? This is the procedure. First of all, try to all information we have to take and mention here in the figure, and then it is very easy to solve the example. See first here. Okay, first of all I will write here quadrilateral ABCD is a parallelogram. Okay, it is given. Because we need to write that alternate angles are congruent like this one. So where we are going to observing now here? In the two triangles. In which two triangles, tell me? In triangle. Alright, BET. Okay? BET and triangle this side DEC. Okay? Tell me now by which test we are going to prove these two triangles similar? Again by AA test. First of all I will write here alternate, alternate, you can write the alternate. Which one? This side BTE, or you may write by one letter also here, because angle T is angle T only. But this side angle we have to write by three letters EDC. Okay, this is from one and alternate angle test. From one, why? Because it is a parallelogram. In parallelogram, opposite sides are parallel. And now one more angle we have to take here, that is alternate. Here it is BET. Angle BET congruent to angle DEC. Okay, this is vertically opposite angle. Finish. Now the two triangles which are similar by A test. Write first BET as it is. And don't copy as it is. Always try to verify they are in one-to-one correspondence or not. See here, T to D. Where is T? Last. So D we have to write last, and then afterwards this E to E. So E is in middle. That means we have to write E is in middle. So which letter is remains? C. Just write where the place is. This is by AA test. Okay friends? Now, what we need? We need this particular part. So it is very easy to write the sides are in proportion. Write all proportion sides. B upon C is equal to ET upon ED. Afterwards, this BT to CD. BT upon CD. This is corresponding sides of similar triangles. Now just look here. What is here? We need every time E. So here it is EE and here also EE. This particular part no need to take. Go with cross multiplication. See what we need. We need DEBE. So take this one here. That is, you can write here ED into BE, and that side C into EP. This is from 5th step. Understand? Like this we can solve the examples, which are very simple one. See here. This is the 9th sum. Last sum from practice set. Look here. In this figure, what is given to us? D is any point of BC. Okay, and angle BAC, this angle is congruent to angle ADC. This particular angle is congruent. Okay, then given to us. From all that information, we are going to prove CA square is equal to CD into CD. Look friends, whenever the example is like this one, at that time CA square means obviously CA into CA means what? Just in previous sum what we studied here, one side take that side and that one side comes this side, then sides are in proportion, means we have to prove the two triangles are similar. Now here in the figure, how many triangles are there? Obviously there are three triangles, A, B, C, this side one and that side one. So out of these three triangles, which two we are going to select? We are going to select CA. CA should be there in both the triangles. Means this bigger one and that side triangle we are going to select. Okay. Once we write all these two triangles, see here I will separate them first. This is bigger one. Okay. And that side triangle which is ADC. Understand? This is ABC, this is ADC. Now look, just look here. Which part they given to us? In this one, they were given to us the two angles are congruent. This one with this one. And remember, this angle is common in both the triangles. Again, this is very easy to prove the two triangles are similar. Again by AA test. Look here, in triangles, we'll write proof part. In triangle ABC and triangle ADC. So first, they're given to us angle BAC is congruent to angle ADC, which is given, and angle C we can write by one letter. Angle C is congruent to angle C, common angle. Okay, therefore the two triangles, these are become similar. Yes, don't copy as it is. Always try to verify whether they are in one-to-one correspondence or not. See here, A to D. Here it is A, that means we have to write first D here. Afterwards, C to C. Look here, C to C. C is in last part. So C we have to write in last part. So which part is remains? A is remains. Write the way. Place is there. This is the way to write one-to-one correspondence. This is by AA test. Okay. Now their sides are in proportion as usual. See here, AB upon DA. This side, BC upon AC. And the last one, AC upon DC. Look, if you make any mistake here, then we cannot get this part here, correct? That is why one-to-one correspondence is only very important in similarity. This is by corresponding sides of similar triangles. Now the next part is what? We need CA square. Means CA should be comes two times. Here it is CA means AC. Here it is. That means this one no need to take. So go with cross multiplication. Let's see what we'll get here. AC square and DC into DC, like this we can get here. See here, CA square means AC square, DC into DC, like this we can solve. Understand friends? This is very important part in this geometry or part 2, Maths 2. Understand?
Hello friends, see here. This is remaining examples from practice set 1.3. Okay, we'll take one by one. We already solved some examples. Now remaining examples we are going to solve. See first. Here, are the triangles in the figure similar? If yes, by which test? See here. Here in this figure, we are going to check whether these two triangles are similar or not. If yes, then they are by which test? See first. What they are given to us in triangle PQR. Here it is 6, 8, 10. Here in element 3, 4, 5. Now see here. We'll take one by one ratio. See first we'll take PQ and LM will take the ratio. That one will get here 2. Similarly, QR and MN. Okay, QR and MN, which is 8 upon 4, will get here 2. Again, this PR and LN, again here it is what? 10 upon 5, which is 2. See first, from first, second and third equation, we'll get same ratio. So from 1, 2 and 3, we get this ratio, this one and this one. All the three ratios are same. Therefore, we can say directly by SSS test, these two triangles are similar. Okay. See here, some examples are like this one. So just very carefully by applying properties, we have to solve. Okay. We'll take the next sum. See first. Here the example number 3, what tells us? In this figure, two poles of height 8 meter and 4 meter are perpendicular to the ground. See here, these are the PR and AC. These two are poles which are perpendicular to the ground of length 4 meter and 8 meter. Okay, if the length of shadow of smaller pole means this is the smaller pole, here QR is the shadow of that one. Okay, smaller pole due to sunlight is 6 meter. That the smaller pole's shadow is of 6 meter long. Okay, then how long will be the shadow of bigger pole at the same time? That means this BC is the shadow of bigger pole, and we are going to find the length of this BC, which is the shadow of bigger pole. See here first, the rays of sunlight are parallel to each other. PQ is parallel to AB. This PQ is parallel to AB. Why these two are parallel? Because they are sun rays. At the same time, sun rays are always parallel to each other. Okay. So now here they are perpendicular and here their corresponding angles are congruent. Why corresponding angles are congruent? Because they are parallel. So PQR and ABC, these two angles are congruent by corresponding angles. Okay, so in these two triangles, PRQ means this right angle and ACB, which is again right angle. So each 90 we can write, they are congruent. And similarly by corresponding angle, these two angles are congruent. Therefore, by AA test, these two triangles become similar. Okay, now their sides are in proportion by corresponding sides of similar triangles. Now just put here this PQ and AB we don't need here. So take QRBC, which is 6 upon X, and here PR and AC 4 and 8. So by simplification we'll get X equal to 12. Okay, like this we can find where 12 is 12 meter, which is the shadow of bigger pole. Okay friends, we'll take the next one. See here, this is a trapezium. ABCD is a trapezium. They're given to us, in which AB and CD, these two are parallel sides. Diagonal AC and BD, they meets at point O. And AB is 20, DC is 6, OB is 15. From that we are going to find OD. Okay, first of all, this is a trapezium, means there one pair of opposite side is parallel. Here AB is parallel to CD. Okay, because of that reason we can write alternate angles are congruent. So which one? This angle DCDO and OBA, these two angles are congruent by alternate angle test. Okay, so in these two triangles COD and BOA, in these two triangles, see first CDO and OBA from one which is alternate angle. Okay, now COD and angle BOA, these two are angle congruent by vertically opposite angles. Therefore these two triangles become similar by AA test. Again, by corresponding sides of similar triangles, all the three sides are in proportion. So here CO and OA, both these we don't need here, so just cross it. Okay, now in these four we have to put all the values what we know. From that we can find OD. So by simplification we'll find OD is equal to 4.5. Like this we can find. Understand? This is OD. Okay, now I'll take the next sum, which is the last of practice set. In this figure, AC, this is AC, and BD, which intersects at point P here. Okay, and they are given to us AP upon CP and BP upon PD or DP, they are equal. So from all this information, look here, this is the given information. We are going to prove these two triangles are similar. Okay? See first. This is the given part. We'll write first given part. What do we have to prove? These two triangles are similar. We are going to prove first. So for in that given thing, we have to write first, that is AP upon PC is equal to BP upon PD. It is given. Remember, their vertical opposite angles we can take congruent, like this one. APB and CPD, they are vertical opposite angles. Therefore, we can write these two angles are congruent by vertically opposite angle. Finish. Now, these two triangles become similar by SAS test of similarity. Like this, we can prove. Understand, friends? So, always try to apply all the properties what we learn in this topic. Remember every property and how to apply that property, and whenever you are going to apply, mention that property without forgetting. Okay friends, thank you.